Hi, this is Ramachandran from onlinemathforall.com. In this video, we are going to see how to solve a complex problem on quadratic equation. Okay, let us consider the problem that we have on the board. That is, if L positive, M positive, N is equal to 0 and L, M, N are rationals. So the roots of the equation M positive N negative L times x square, positive N positive L negative M times x, positive L positive M negative N is equal to 0. So the options we have real and rational, real and irrational, imaginary and equal, real and equal. So these are the four options we have for the question. Okay, when we see the target of the question, that is how the roots of the given quadratic equation will be, and the roots the options real and rational, real and irrational, imaginary and equal, real and equal. So when we see these things, the target of the question, the options given, so it's very clear that we have to examine the nature of the roots of a given quadratic equation. So to examine the nature of the roots of any quadratic equation, we just have to find the value of the discriminant, that is b square negative 4ac. So we have to find the value of this particular discriminant, because b square negative 4ac is called as the discriminant of the quadratic equation. So once we get the value of this discriminant, once we get the value of b square negative 4ac, so easily we can decide the roots, how the roots of the given quadratic equation will be. So the roots are real and rational, or the roots are real and irrational, or the roots are imaginary and equal, or the roots are real and equal. So okay, so now our aim is to get the value of b square negative 4ac to give answer for this question. So to get the value of b square negative 4ac, we have to compare the given quadratic equation to the general form of a quadratic equation, a square positive bx positive c is equal to 0. So when we compare, so we get a is equal to m positive n negative l, and b is equal to n positive l negative m, and c is equal to l positive m negative m. So in this discriminant b square, so we can replace b by n positive l negative m, that is the coefficient of x in our quadratic equation. So n positive l negative m whole square negative 4 times the value of a is nothing but the coefficient of x square, that is m positive n negative l times the value of c is constant term, so that is l positive m negative n. So the next step what we have to do is we have to expand this n positive l negative m whole square, and then we have to multiply these two terms, m positive n negative l and l positive m negative n, and then the result has to be multiplied by 4, and then this has to be subtracted from the result of n positive l negative m to the power 2. So definitely it won't be a simple work. So first we have to expand the one n positive l negative m, because we have 3 terms in the parenthesis, and then we have to multiply the 2 m positive n negative l, l positive m negative n, then the result has to be multiplied 4, and then subtracting. So all those works are not simple, and also it will take more time. So okay, let us try to do the same problem in some other way. Okay, so 1 second. Okay, so now since the way already we tried is not easy, so we are trying to do the same problem in some other way. So for that I'm just trying to use the given information, that is l positive m positive n is equal to 0. So I'm just trying to use the information given in the question. Okay, first let me write that information, l positive m positive n is equal to 0. Again I write the same information, l positive m positive n is equal to 0, l positive m positive n is equal to 0. So I have written the same information 3 times. So in the first information, the first time l positive m positive n is equal to 0, I'm just going to take negative l on both sides. So here the student may have a question. So in the given information, why do we take negative l on both sides? So I tell you the reason bit later. So when I take negative l on both sides, so the positive and negative will get cancelled. So we get m positive n is equal to negative l, and here in the second I'm just going to take negative m on both sides. So positive and negative will get cancelled, so we get l positive n is equal to negative m, and here I'm just going to take negative n on both sides, When I do so, positive and negative n will get cancelled. L positive m is equal to negative n. So these are the things I get here. Okay, so in the given quadratic equation, that is m positive n times x square, m positive n negative l times x square positive n positive l negative m times x positive l positive m negative n is equal to 0. So this is a given quadratic equation. So in this quadratic equation, instead of m positive n, we can write negative l, because already we got m positive n is equal to negative l. So in the given quadratic equation, so wherever we find m positive l, it can be replaced by negative l. Then we will get negative l times x square, because we have taken negative l for m positive n. Positive for n positive l, we can take negative m, because when I used the given information second time, so I got that n positive l positive n positive l both are same, so that is equal to negative m. So n positive l can be replaced by negative m positive, and l positive m can be replaced by negative n, because this one I got from the given information when I used it the third time. So here I got it, l positive m is equal to negative n. So negative n is equal to zero. So here from the given quadratic equation we have made some changes. So from the given information l positive m positive n is equal to 0, we got some values for m positive n, l positive n and l positive m. So I applied those things in the given quadratic equation. So okay, let's do the next step on our next page. So in our previous page we had negative l times x square. I'm just going to write the same thing here. So when we add negative l, we'll get negative 2l times x square, and negative 2m times x, negative 2n is equal to 0. So on the left hand side of the equation, when I factor negative 2, I'll be getting negative 2l times, I'm just going to factor only negative 2. When I factor negative 2, I'll be getting lx square positive mx positive n is equal to 0. Now I'm just going to divide by negative 2 on both sides. So here negative 2 will get cancelled. So we get lx square positive mx positive n is equal to 0, because 0 over negative 2 will be 0 again. So see the given equation now it has become more simple. Lx square positive mx positive n is equal to 0, because here the value of a is l, value of b is m, the value of c is n. That is I'm just going to compare the given equation with the general form of a quadratic equation, ax square positive bx positive c is equal to 0. So when I tried the same problem previously, I had a bit complicated, but this time it's very simple. So because we got a is equal to l, b is equal to m and c is equal to n. Now I am trying to find the value of the discriminant b square negative 4ac. So b square negative 4ac is equal to, so the value of b is m, so I take m square negative 4, the value of a is l, and the value of c is n. So instead of writing m square, better I can write negative m to the square. So because the m square or negative m whole square, so we'll give the same result m square. So there is no change in the value when I write m square as negative m to the power 2, because when we take power 2 the minus will become plus. So for some reason I just take negative inside the parenthesis. Since I am taking this negative for m, the value is not changed. So even if you take square for negative m, you will be getting the same result m square. Okay, in our previous page we know that negative m is equal to n positive l, because from the given information like l positive m positive n is equal to, we just have 0, and in this I'm just going to take negative m on both sides. When I do so, positive and negative m will get cancelled, so I'll be getting L positive n is equal to negative m. So for negative m I can take L positive n. So for this reason only I just took negative sign for m. Since I'm taking this negative for m, the value has not been changed, so for instead of negative m, better we can write L positive n whole square and negative 4 ln. So now we can expand this using the identity that is a positive b the whole square. So when I apply the identity a positive b whole square for L positive n whole square, the result will be a square positive b square positive 2ab. This is the result for the identity a positive b whole square. The same I'm going to apply for L positive n whole square. So when we compare L positive n whole square with the identity a positive b whole square, instead of a we have L, instead of b we have n. So the same result a square positive b square positive 2ab we are just going to apply for our problem L positive n whole square. When I do so, I'll be getting L square positive n square negative 2 ln. So at last we have negative 4, I'm sorry, it has to be positive ln, and at last we have negative 4 ln. So in the next step what I'm going to do is I'm just going to simplify these two terms. So when I simplify positive 2 ln negative 4 ln, I'll be getting L square positive n square and negative 2 ln. So it's in the form of a square, one second, it's in the form of a square positive b square negative 2ab. So if I have terms like this, we have an identity for this one, that is a negative b the whole square. So instead of a in our problem we have L, instead of n so we have negative at the middle because in the identity we have a negative, and instead of b we have n, so we get L negative n the whole square. So we get b square negative 4ac is equal to L negative n the whole square. So okay, let us proceed the next step in our next page. So we get that b square negative 4ac is equal to L negative n the whole square. So hereafter we can't simplify. Okay, so from this we have to decide how the roots of the given quadratic equation will be. So they are real and rational, or real and irrational, imaginary and equal, or real and equal. So these are the things we have to decide from this result. Clearly I can say one thing about the value of b square negative 4ac, so that is it will be greater than 0. Here the students may have a question, sir, how can you be sure that the value of b square negative 4ac can be greater than 0 from the result L negative n the whole square? Because clearly outside of this parenthesis we have positive sign, because we don't have any sign, so we can assume there is positive sign. If there is negative, so we'll have negative, but we don't have negative, we have positive. There is no any sign, so we can assume there is positive sign. Even inside the parenthesis, if the value of L negative n is negative, if the value of L negative n is students please listen carefully, if the value of L negative n is negative, since we have whole square, the value will become positive. Already we have outside of the parenthesis we have positive, so definitely since even if you have a negative sign inside the parenthesis, since because of the whole square, so the term will become positive. So positive again will be positive. So definitely the value of b square negative 4ac is going to be greater than 0. And also one more important thing we have to consider here, so that is we have square for the whole term. We have only one term, that is L negative n, so for that one we have whole square. So from this it's very clear the value of b square negative 4ac is greater than 0, and also here perfect square. So since it is greater than 0, the first thing what we can say is it's real. Since the b square the value of b square 94 is greater than 0, so definitely the roots are real. Only b square 94 is less than 0, the roots will be imaginary. So already we know the statements, what will happen if b square 94 is greater than 0, less than 0, all these things we know. So since the value of b square 94 is greater than 0, the first thing what we can decide is the roots are real. And then the other thing, and also the value of b square 94 is a perfect square. Since it's a perfect square, definitely it can't be irrational, it will be a rational number. So the statement, I mean the addition, what we are going to give here is from the value of b square negative 4ac, the roots are real and rational. So two decisions I have made, one is real and other one is rational. So for my decision real, I say the reason the value of b square negative 4ac is greater than 0. Since its value is greater than 0, I decide the roots of the given quadratic equation would be real. My second decision is rational. So why I say the roots are going to be rational? Because the value of b square negative 4ac is a perfect square, because we have whole square for l negative n. So since we have square for the whole term, it's a perfect square. Since it's a perfect square, it can't be irrational, it will be rational. Like instead of the square root, if you have 4, so 4 is a perfect square, so the value of square root of 4 will be 2, so it is rational. So that is why I decide the roots are going to be rational. Okay, now let's come back to the original page. Please give me a moment. It takes a bit time. Students, please wait. Okay, so we desire the roots are real and rational. So option A is correct. Roots are real and rational. So when we see the problem like m positive n negative l times x square, when we see the coefficient of x square, coefficient of x and the constant term, in each of these we have three terms, m, n, l. So when we see the problem, immediately we may think so it will be little bit difficult to solve. So it's not like that. We just have to use the given information and we just have to try to find the way so to solve the problem easily. So I hope the students will be able to understand more clearly now. Okay students, for more videos like this, please visit www.onlinemathforall.com. Thank you.